we see here being the drawing generation, as this is sort of what you guys have expressed interest in. As we go forward, we have plenty of other products we can always talk about, but for today's purpose, we will focus strictly on the drawing generation. So, big reason why a lot of companies reach out, reason you guys have reached out to us as well, is the fact that manual drawing of converting those 3D models into 2D manufacturing papers is very time consuming and quite costly when you have the design engineer all of these models over into drawings when their time could be better spent elsewhere doing new design, more innovative work. We also see a lot of times that made in the leading to errors down the line in manufacturing, rework having to be done, or scrap and parts getting sent back and forth. As well, in larger companies, we see a lot of issues with inconsistency where a has not learned the MockVision standard of how to draft and how to sort of detail and tolerate, which then makes it much different when someone who's been working there for a decade does it. You could both be drawing the same part, and if they get sent to the manufacturer, you might end up with two almost different parts just by virtue of having designed them. So these are sort of problems or issues that Draft8 kind of aims to solve all over. Now, I'd love to learn a little bit more about your team, Derek, and sort of what challenge you guys kind of facing the most and what really brought you into the conversation.
Is there any of these particular challenges that are most most driving this conversation?
Most challenging is we spend more time to transfer the 3D model to drawing, and the different engineering make the different the annotation.
Okay.
Yeah, that's honestly what we see.
So we want to use the AI make the same the basis and the basis standard. Yeah.
Okay, awesome. Well, that's actually what we hear from a lot of our customers. Usually they reach out to us just going over the time consumption and wanting to reduce the time spent drawing, but they typically renew with us and want to stay with our product suite, really because they end up not only reducing time, but like you mentioned, the amount of errors or inconsistency you might see between different drafters. Now, jumping forward here, just want to give a little bit of background about who we are as a company. So we were founded back in June of 2023. We're a backed company, so we are well-funded, well-capitalized future, and keep delivering new and great products sort of as we continue on. And we currently have thousands of engineers who are using Draft8 every single day, with some of the companies you could see here, brand names that you might know: Bosch, Tesla, Denso out in Japan, Korber in Germany, Denison over in the Netherlands. And just taking a look, you can see back in 2024, we generated over 10,000 drawings. Last year, we did over 200,000 drawings, and this year we are currently on track to automate 1 million drawings across all of our customers. Now, one thing I want to mention before we get into sort of more of the product features is really the security. As cloud software, it's always going to raise flags in an IT department, and we want to make sure that customers know that this is something that we are able to sort of clear early. And we do have SOC 2 Type 1 certification, and we currently have our SOC 2 Type 2 certification in waiting. We're just waiting to finish up our audit. Within the next 1 or 2 months, we will have that certification. The way this works is your AI is going to be stored on our AWS server in the US. And what happens when you want to get a drawing done, it will send your data to the cloud, to our AI. It will generate the drawing and send it back to you. Now, one thing I want to note is every single one of our company's AIs is completely independent. So in this picture here, we have the DraftAid server. This sort of encapsulates the broader AWS system. Each company exists in its own box. So every AI, Bosch's AI is exclusive for Bosch. Tesla's AI is exclusive for Tesla. So any data that we get from Tesla, we use to train our AI on or their AI on. None of that data or none of their features would get used on Bosch's parts, for example. And the main reason behind this, just beyond security, is Mockvision would have their own way of how you might like to draw, how you set up, how you have, you're going to do chain dimension, the way you do G. We want to make sure your data in a drawing to get automated through on the Mockvision way or the Tesla way. Now, there's currently 2 stages of AI training. So what Sean alluded, what you're going to see today in this demo is our base model AI. So this is an AI that has been trained off of a bunch of internet data. So not the best drawings you've ever seen. This is what is freely available to us, as again, we're not going to build an AI out of the, or show you Bosch's AI or Tesla's AI, for example. So what you can expect is they won't be the most amazing drawings, nothing that you would say is mind-blowing or give me your money now, I want to purchase. The way this system really works and kind of takes off and adds value to you as a customer is through our fine-tuning process. So what happens when a customer gets on board with our company? We will ingest all of your data. So you guys could send us 1 to 200 parts and their associated drawings. We'll spend some time with one of your engineers just making sure we understand the Mockvision way of drafting parts and making sure that we know what your formats and standards are. And we will then spend the next 2 to 4 weeks ourselves, this does not involve you, training the AI system off of your drawings, making sure that we are getting consistent output. And from there, we would expect to about save 80 to 90% of the time spent drawing, whereas what you'll see today is honestly probably closer to that 30 to 50% range in terms of time saving, as again, it's not a custom tuned AI to the Mockvision way. So typically this is sort of the ramp up period that we see across customers over that initial 4-week period of onboarding our software. The first week they use DraftAid. Again, it's not going to be saving you that much time. You're looking at about a 30% time reduction in your drafting of parts. By week 4, you're looking at close to an 80 to an 85% improvement in the time saved drawing over time. Every time you submit or make changes, that automatically gets reflected to our AI and it will learn off of that data. So just want to go over what do I mean it improves over time or it gets better with training. So these are these 6 areas that the AI will learn from your historical drawings. So things like templates and title blocks, any iProperties if you're using Autodesk products, or any metadata or MBD you put into your model, it will start to learn from that. The dimensioning style, on what type of parts do you use ordinate versus chain dimensioning? We're going to sort of, as parts come in, it will know what you would typically do based on your history. Things like datum selections, view selections, when are you adding breaks into your parts, and also just get a lot better at feature recognition. I know some of the parts that you guys have sent were a little bit more complex than some of the parts that we see. And these are the things that would really take off with that fine-tuned AI. Now, again, as I mentioned earlier, every drawing you edit and save feeds back to the AI system. So your accuracy at week 4 is 80%. Week 10, week 20, you're going to be jumping 85, 90, 95% is typically where we're going to max out. We will never be perfect. It will never be a fully automatic solution. It's automated, but it is by no means completely automatic and hands-free. We are definitely a tool built to enhance and give time back to your engineers, not to replace them. Now, something I want to show is just a brief sort of view of how does our AI actually visualize and see your data? So when we submit a drawing, how does it look into the history of other parts to then go in and understand sort of what to do, where to tolerance, and how to tolerance? So this is just a quick map of one of our customers who gave us access to some of their data and all of their parts. So what you can see here is actually a map of our system, sort of grouping all these parts based off of similar features. So what this allows us to do is if I were to submit a part that exists within one of these clouds or near one of these clouds, it will then pull from a previous part in history and say, hey, this is how we dimensioned this. This is how we toleranced it. Based on these are likely probably a similar part for a similar function. So I know, should I be using a whole table here? Should I be tolerancing using ordinate dimensions or chains? However you've done it in the past, this will basically look at that and learn from there. Now, I just want to pause here. Any questions so far? I'm happy to pause, take questions. Otherwise, we can continue on.
None so far.
Okay,
Nice.
awesome. So I'm just going to show about 3 examples of a fine-tuned system versus a base model AI that you're going to see in the demo here today, and then we can jump right into the demo. So taking a look, this is a part here. It's a simple machined part with a pocket inside here. We have some dowel holes and some other hole features on the side of the part. Now we can see this is an okay drawing. I wouldn't say it's anything amazing. We are missing a couple dimensions on things like the dowel holes here. The overall sort of views and structure of this is not what the customer would want. Again, this is what they saw based off of the core AI system or the base AI, not what you would get after that 4-week training period. After the 4-week training period, our customer got something that looked like this. Now, this is a much more feature-rich document based off of their standards and how they like things to be drawn. So you can see here, we have many section views on all of the parts. We've dimensioned the depth of these holes. And now instead of that one ISO view, we have 2 fully rendered ISO views in the bottom corner, specific to the standard of this company and how they do their parts. Going forward again, we have this a slightly more complex part. This is a turned part that we can see here, has a lot more features with holes on the side. And what we're looking at here again is the base AI system that has been untrained. So it recognized that these holes were here, but it did not dimension any of them. It did not do any detailed views on some of the holes on the side here, or really even dimension any of these. It was able to give us a nice section view and call out some of these other overall dimensions, but by no means would I say this is a complete drawing. There's still probably going to be maybe 40% of the time that you would typically spend on this if you're to draw it by yourself is still going to have to happen from the engineer here going back and correcting this drawing. Now, again, after that fine-tuning process, this is what that drawing looked like for our customer. So we can see in the top left here, we have a hole table that is now calling out every single hole on the front of this flange piece here. We have a differently rendered ISO view. We have a detailed view of one of the holes here. So we have a much better idea of how to actually go and manufacture that. As well as we can see this has picked some datums, added a little bit of GD and T, and there's even hidden lines now being exposed. So you have a better idea of what this part would look like, again, based off of the customer's specific requirements on how they would draw a part like this. Going to pause here again. Any questions? Happy to kind of cover them now or just get your general thoughts on sort of this system here.
No question, everything is clear.
Okay, amazing. So I'll jump forward a little bit more here. We have one more part to kind of go through. So this is a larger part. We can see here it is a sheet metal piece, quite big, done in 2 pieces. So in our original, again, base AI system, we're getting these 2 ISO views, the rendered view here, as well as the flat pattern right below that. Or sorry, this is actually the this is the base model view. It's split it up into 2 drawings or on 2 sheets. Again, we have one ISO view, caught some of the details, didn't really get some of the angles or call them out very well for the manufacturing side of things. Whereas in here, you can see we have at the fine-tuned version, we have a much better version of this drawing, flat pattern, and then 2 ISO views all within the same sheet, just making things a little bit cleaner, again, specific to how this customer liked this part. So now for the fun part, we can jump into the demo and we can actually take a look at some of the parts that you guys have sent over. So I'll stop sharing my screen here and I'll get it back open in 1 second. So I'm just waiting for SolidWorks to load on my laptop. Sometimes it takes quite a bit. There we go.
Good.
All right, let me know when you guys are able to see this and we can get started.
Yes.
Yes. Yes.
All right, beautiful. So this is one of the parts that you sent over. So the way that draft aid actually works, actually, sorry, I'm going to share my whole screen instead of my window here because that's going to matter in a second. Okay, there we go. So the way draft aid works, this is actually a native integration into your SolidWorks. This is not some third-party program where you're having to export all of your models, bring them in or upload them to like a third-party program, and then bring them back into SolidWorks after. We actually exist in the same toolbar as your features, markup, everything else that you would do in SolidWorks. You can jump over here. You'll see we have the draft aid tool over here. And we have a couple of options. So we have draw current part. So this will draw the currently open part. Or if I had an assembly open, and let's say I have 50 parts in it, and I want to draw the first 10 of them, I could highlight those 10 parts and click draw multiple parts. It will now automatically draw all 10 parts simultaneously. So if I want to draw this one part, I'll click draw current part here. And then this portal will open up. So while draft aid is natively built into SolidWorks, it is also a desktop application that you have full access to where when you upload your models, they will automatically go into here, get sent to the cloud, get drawn by our AI, and then sent back here for you to go and review. Now, when models are automatically drawn, the drawing will live right beside where your model is already saved. So if you're using PDM or a Vault, this will automatically go right next to your file. Although we do have the option, if you guys want to configure it in a different way, where you have drawings stored separately from the parts, that is something that we can do and set up with you and your team, however you guys like to sort of import and work on parts. Now, as I mentioned, draft aid is a native plugin to your SolidWorks. We can also upload parts directly into this software without even having to open our CAD. So I could go into my Vault, I could copy 50 files and just drop them directly into here, have them draw all of them without even ever having to open up my CAD platform. Now I can take a look at the part that we just dropped in here. So we can see here, it got just about all of the features. This is a pretty decent drawing overall. However, I still think we're missing a couple of things. Taking a look at these sort of curved arc holes, it wasn't able to catch those. Again, this is a base AI model with something like our fine-tuned and trained AI, and we have historical data to base off of. We would be able to call that out. But taking a look at the counter bore here or countersink, we're able to see that. So we have that 7mm through hole and that 15mm down by 3mm counter bore as well. Out of curiosity, do you guys think this is a good drawing? Would this have, how much time would this have saved you? Knowing that it's not in your standards when it comes to things like the title block and all of that, as again, that is something that we would work specifically with you and your team on.
back.
Yeah, it sounds pretty good to us.
Okay.
Okay. Awesome. Well, love to hear that. Something else I can show maybe before we get into more feedback is, let's say I'm looking at this and these sort of dimensioning here, it's a little bit crowded, it's somewhat hard to read, or maybe I want to have my ISO view moved over to the left. What I can do here is I can click this chevron and I can actually open up the solid drawing. So when I click this, it is now going to open my drawing in SolidWorks for me, where I can now jump into here.
Can you zoom
And
in
if I
a little
want-
bit? Perfect.
So let's say, as we saw before, this was kind of crowded sitting over top of there. So I could sort of move this out to here. Maybe I want to have my ISO view over into this corner here. I want to have this pulled down a little bit. I can just move around everything that I'd want to do. And once I'm done that, I can click Upload Correction. So what this is going to do is this is now going to upload all of these changes I've made to the DraftAid server, to that DraftAid program, and it's also going to tell our AI. We can see down here, this says correction has been submitted. So now we can see those changes I just made are reflected here in DraftAid. And now the status of my part actually sits as corrected. So now the next time I was to go and throw in a part that looks similar to this, it will make and learn from those changes that I just made. Furthermore, if let's say there was major changes that you had to make and the part drawing was not good enough for you in any meaningful way, what you can do is when you open this up, we can actually give this drawing a rating. So you can tell us 2 thumbs up, this was amazing, 1 thumb up, it's a good drawing, it saved me some time, but not perfect, or thumbs down, I had to do too much work to make this a usable drawing. And what happens when you do that, let's say you wanted a whole table. So if I were to click, I want a whole table, and I go thumbs down, what's actually going to happen is that data or feedback gets sent directly to our team, to our customer success team, and to the account manager or to the customer success manager for MacVision. So this means that a real person is going to look at what you just sent every single time you make a rating on a drawing, and that feedback they can use to help fine-tune your AI, not just relying on sort of the automated corrections on automated learnings. If there are specific things that they think they could do faster than having the AI learn over time, they can go in behind the scenes and make those changes for your team. Important distinction from a lot of teams is they don't want everybody's feedback to be taken into account on the automated training or even this training. So if you have a fresh out of university worker who is making drawings and they make changes to them after, you don't want the AI maybe learning off of their habits because they may not know sort of everything that they should, that maybe a senior engineer would. So you can choose what engineers within your company who actually has the power to train that AI system automatically, and who does the AI look at when they make changes and give weighted values to each and every person within your organization. Any questions so far? Otherwise, I can show you sort of the rest of the feature set here with some of the other parts you sent over.
So a quick question is that you mentioned that there's something that hasn't been marked, like the curve hole. So if we want to add something or correct something, so we just add it on our SolidWorks or?
Yes, exactly. So if you were to add that to your drawing within SolidWorks, the next time you have a part with this, you would be able to see that.
And then update it like the correction steps or?
You wouldn't have to do it in here. You could and just say, like, hey, maybe if let's say if you made that correction within SolidWorks and you uploaded a didn't see this happen, then I would come into here and write it. So a actual human would go and see that feedback and say, hey, I'm not getting dimensions on these curved holes here. But typically, you would probably get dimensions on this. The reason we're not, again, this is a base AI system, and my guess would be some of the models that we trained this on didn't have these kind of curved features based on what we were able to get freely online. If we take in a host of your parts with all sorts of geometries that you guys have dimensioned before, this would get dimensioned right off the start. Or if you prefer to use whole tables, things like that, it would recognize that this is a part that would want to have a whole table. Does that make sense?
So we're curious about the learning part that you mentioned previously, like the 4 weeks learning to let it be more accuracy. So if we found something that is not marked or not correct, we just mark it, or what should we do to let your AI train?
Yeah, so for more minor things, jump into SolidWorks, make that change yourself, add in the extra dimension, move things around, add a whole table. If there is bigger things that you are finding, hey, the AI is never really catching these features, or when we upload these type of sheet metal parts, we're not getting a drawing that we necessarily like. In those circumstances, then you can just type your feedback into here, and that will go to our team, go to your customer success manager, and they will work specifically with you to make sure that doesn't happen again. So the automated system, it's much easier, works essentially immediately. But if there is bigger issues where things aren't getting caught, write it to our team. We will get on a call with you. We will take a look at your parts every time they get submitted, so we can go behind the scenes and make sure that what you're expecting is what you're actually going to get.
Okay.
Mhm.
So it's more like a human helping process, or
Yeah,
like a bigger issues.
So essentially,
That's more for
there's yeah. Sorry if I can jump in, Robert. So there's really three elements here, right? The first is what's happening during the initial implementation. So when we first start working together, you will provide us with a whole set of existing drawings, and we will do that AI training on your behalf. So that happens in the first 2 to 4 weeks. And then we say, okay, the Mock Vision custom AI is ready for you to start using, and your team will start using it. Right? So that's the initial training. Then once you start using it, if you get any drawings back that you need to make corrections on, you can just make the changes in SolidWorks, as Robert showed. And once you hit save or you hit upload correction and save, that will automatically teach the AI. That doesn't just happen for the first 4 weeks. That happens as long as you use the product, it's continuously getting better. So those are the two main ways the AI will actually learn from your drawings. The third way you can share feedback is what Robert mentioned there, which is the direct feedback in the product. So like, I always want this type of part to have a whole table, as an example. That is feedback that goes directly to your account team, which is your customer success manager and your account manager, and they can make manual changes if the AI is not learning fast enough, or if we need to make more drastic changes. So those are kind of the three different ways that the AI, that the product, the drawings get better over time.
Yeah, and
Does
just
that,
to add in here,
yeah.
when Sean says the person goes in to make corrections, they aren't making corrections to the drawing. They are making corrections to the actual AI system as a whole in the back end. If there is some sort of coding change or math change or how it views certain parts, that's what they're changing. They're not jumping in here and doing the drawing for you by any means.
Right.
OK，我有蒙问，凯哥、马哥，就是你们到目前为止那个 demo 有简易的 demo 有什么想法吗？但是目前都还是用他们的。
就是没有讨论到是谁要去处理这件事。
对，
因为那时候后来我收到的是就是11、12号就是
OK，那我再请他就是继续一下这样。
对。
马哥好像是你的麦。好。OK, we can continue to demo our part.
Okay, sorry. I know there was some conversation there. Was there any additional questions from us, or
No question. Yeah, everything's okay. So we
just
can
clarifying?
proceed. Yes, we can proceed to another next step.
Okay.
Okay, what I'll show before we can jump to the next step of the presentation, just because we see how the drawings work, I could just show you what would happen if you wanted to upload, let's say, 20 drawings. You don't want to do it one at a time. That could still be quite time consuming, or open every part in SolidWorks and click submit drawing. I can actually jump into here, into this portal here that we have, and I could upload all of the parts that we have. I'll make sure I'm not going to upload the same one. So if I were to upload all these parts, sorry, I just want to get rid of the one we've already drawn. It's this one. I can now just open this, and you'll see up here we have a little uploading files. So all 20 files are getting sent straight to the AI system, and now they're going to start drawing. And what's nice about this system, it's not drawing these one at a time. All 20 of these will get drawn at the same time. It will take anywhere from about 30 seconds to 3 minutes to draw all of these parts. So we actually have had a customer who had over 20,000 drawings that took them, I believe it was about maybe 3,000 or 4,000 hours, and they wanted to test and see, we've already made these before, but let's do a case study and see how long would this take us to do with this system. And we cut that down from about 2,000 hours to, I believe, just over 300 or 400 hours. So within 24 hours, we uploaded, I think it was 20,000 parts. Every single one got drawn, and or 2,000 parts, sorry, they all get drawn within the span of 24 hours. And then all the corrections that needed to be made were done within a week by one person. Whereas typically that could take, or by, I guess, 2 people. Whereas that typically took them over a month's work, was now done in 2 days. So we can see here some more parts are kind of popping up as they get finished. So again here, got most of the overalls. We're catching the holes. I still think some features are missing. So the pressed in PEMs here on this view here aren't getting caught, and looks like we might have not got dimensions on this flange down here, or all of the dimensions on some of the extra features here. That said, again, this is something that we would expect with our base AI system. As mentioned, we'd expect anywhere from 30 to 40% time saving. Whereas once we do that 4-week training with you and your parts, something that comes in like this, we would have no problem spitting out a drawing that's 80, 90% complete to the mock vision standard on how you would do a sheet metal part like this. Let's see here if there's any other parts that are done. So we can jump up into here. Another part looks pretty good. So we can see it's catching most of the features. It's a little bit crowded. We can see here it didn't get the chamfers on the corners there or the keyhole slots here. But again, these are things that as we work with you and your team, these are things that get caught from moving from that base AI to that fine-tuned or trained AI. See here, we missed the chamfer on the side as well. But again, I would say this is very much expected and sort of what I would expect to see with our base system. But over time, as it learns, gets better, this is stuff that we know can get better and why our customers stick with us for so long. So we definitely have to put our customers often have to put a lot of faith into us as a company when they see these drawings, knowing that it's going to get better and they're going to work with us and we will get better. And just a very big proof of that is our what we do when we get on board with a customer, we give you a 3-month trial period of the software. It is a paid trial just because we do have to spend quite a lot of time and money on the actual training of that AI system. But only 1.2% of our customers have ever quit after that 3-month trial. So again, if these parts aren't what you like, that fine-tuned system will be the parts that you like. Out of curiosity, how does a part like this look? Clearly, we can see it's got some of the overalls, but we're missing quite a few dimensions. It does do a hole table to catch just about all of the holes, but I'm curious, based off of what you're seeing in these past few drawings, I'd love to get your feedback or thoughts.
And
所以
as
目
we
前
mentioned,
看
sorry,
起来
yes,
有什
Derek,
么
go
想
ahead.
法吗？
We can also send these drawings afterwards. I know, Derek, you had asked versions, so we can send this to you as a follow-up.
Oh,
So you
okay.
can see, you can review afterwards as well. So of course, we'd love any feedback now, you know, but as Robert has mentioned, this is kind of expected for our untrained version of the AI. But hopefully this shows you a little bit about the workflow, the speed at which Draftaid can produce the drawings, and give you an understanding of the general capabilities. So yeah, just to wrap up here, to kind of discuss how we work with our customers. As Robert mentioned, for all of our new customers, we offer a 3-month pilot period. That 3-month pilot period is a paid pilot, but we offer it to all new customers in the first year because we want them to get comfortable with the fully trained AI and experience that before committing to a full contract with us. So basically the way this works, in the first 4 weeks, we go through the fine-tuning process. So you share with us, we would meet with you, we would go over your drawings to understand exactly what your requirements are. We would get the drawings from you and the associated 3D models. We would take this away. Draftaid handles the initial training process. So we do all this work for you to train the AI. And then we would give it to you at the end of about that 4-week period. We would provide that trained AI to you to start using. You would then use it over kind of another 4-week period, feedback during this time, and we can make changes during this period as needed. After this period is complete, we consider the implementation process done, and then you can use it more broadly across your company with the fully trained version. It will continue to get better over time as you use it more and as you make more corrections to the drawings or make more updates to the drawings in SOLIDWORKS. It will continue to get better over time, but this is the general overview of the first kind of 2 months of working together during that pilot period. So let me know if there's any questions either about the technology or about the implementation process. Yes, this is our presentation for today. Any questions?
All right, can you give us a few seconds?
Yeah, no problem. No problem.
凯哥，喂，凯
Yes.
哥，那个我们刚跟什么谈，讲了一下，就是说他现在这个好像就是订阅会员之后，如果有订1年期或是什么之类的，然后他就是可以，呃，他提供的一个训练流程，就是训练时间大概1到4周，对，然后 release 是4到8，然后中间就是一直在不断交流这样。那接下来下部分是就要直接跟他谈到说会请采购去跟他接洽吗？还是嗯？OK，然后那我这边就是先跟他说，我们先拿到他的那一些 图档，然后我们内部讨论一下，就是如果 OK 的话，我可能就是请那个采购的同事去跟他做接洽谈那个订阅的费用这样。OK OK 好，那我跟守恒确定一下。有听得到。对对，等下确定一下。好，OK。哦，但哦好，这个版本我后续再跟他详细说明。然后那个我先跟守恩确定一下，等一下要跟他讲那个采购的事情。对。
Okay. Any additional questions before we let you go? We can also follow up over email. Derek, I can send you the drawings as requested, and then we can follow up and discuss over email regarding next steps. If you are interested. Sound good?
All right, yeah, thank you so much for the demo today. So please send us the drawings that you just finished so we can have a quick view of what we will get. That's okay.
Sounds great.
So
We will definitely do that.
Yeah, we will need some time to go through the drawings and make some discussions. And if we have any more questions, maybe we will use emails to contact with you. And also, if it's looks like pretty good, or we will start our next step, and maybe other teams will involve in this project.
Okay, sounds great. If it's okay with you, I will send the drawings tomorrow my time. I know